Morning, good afternoon, good evening, wherever you might be, and welcome to a physics post. It's been a long time since I've done a physics post, and this one is about adaptive optics, adaptive measurement devices. The Nobel Prize Committee recently provided yet another stellar example of how understanding of the scientific method has broken down at the highest levels. I'm not complaining about black holes today. I've already done that. Today I'm complaining about the scientific method in particular, or how it's applied. One of the prize winners took data using a Hawaiian telescope with adaptive optics in order to see things that cannot be seen in any other way. She taught other facilities how to perform similar measurements, as in her measurement device could only see the objects it was studying if the optics were specially shaped so that they saw the objects under study. While objecting to this methodology sounds rather bold, I think that when you see the technical details, you'll start to understand why this was a dangerous thing to celebrate. So I recommend clicking on the blog post below because it has a nice image of an adaptive optics setup where light from the telescope comes in with a distorted wavefront. The adaptive mirror shapes that wavefront so that it's flat, and there's a beam splitter, there's a wavefront sensor, and a control system that tunes the mirror, but it's helpful to see the picture. At first glance, such a setup doesn't look problematic at all. When we focus a microscope on a sample, we have to put the lens in a special configuration so that the image isn't blurry. Every lens has some defect, so why not add a deformable lens that can compensate for these defects? The thing that is troublesome about adaptive optics is that when they are pushed past their intended limits, one ends up creating an image of the adaptive optic, of the mirror itself, rather than of the sample under study. So, such a system can create images that look exactly like the stars that it wants to study. And it becomes very difficult to figure out if one is measuring something that is actually there, or if one is measuring an artifact of the measurement tool. Identifying the location of a spot may become especially difficult with such a system, as relative and absolute reference points get mixed up through steering effects from the adaptive optics system. When one combines this sort of measurement device with wishful thinking about black holes, groups of people may draw strangely overzealous conclusions about ambiguous data. The data point didn't fit? The sky must be too noisy today. We should try again tomorrow. Repeat this process for 20 years. So I'm going to quote a description of a study that claims to support the existence of black holes in the center of our galaxy, but really, if you look at the particulars of the measurement, they just tracked the position of stars near the center of our galaxy. So they wrote, "The stars in the innermost region are in random orbits, like a swarm of bees," says Gillison. However, further out, 6 of the 28 stars orbit the black hole in a disk. In this respect, the new study has also confirmed explicitly earlier work in which the disk has been found, but only in a statistical sense. Ordered motion outside the central light month, randomly oriented orbits inside. That's how the dynamics of the young stars in the galactic center are best described. So there are multiple problems with this statement, because if you start assuming that certain things are on a disk and some things are not, you're working with objects in 3 dimensions and pretending like they are in 2 dimensions. That can make you make mistakes. So I believe the measurements. I just don't always believe the interpretation. that scientists give to their results. To me, this looks like they saw random behavior in most of their data. I mean, 28 stars, random. And then selected out only the 6 data points that seemed to move in a coordinated fashion around a central point, if they imagined that they were on a disk, moving in a disk. So there's a video in the post linked below that I recommend that you watch, and it shows their animation of the data they took for 20 years. So it looks like data that would have been taken like a snapshot, once every month for 20 years. But it's very misleading, this sort of presentation of the data, because each data point was taken individually, and then they compiled them all into a composite image, which gave them a lot of freedom. It's a bit... So, and if you look at the data that won the Nobel Prize, all of this belief in the existence of a gigantic black hole governing the motion of 6 stars or whatever, it seems to be primarily based about the motion of one star in particular that seems to make a little looping motion. And given mistakes that I've seen in other astronomical calculations, one might wonder if the star was what made that strange 20-year-long motion, or if the measurement device itself, as in the Earth, made such a 20-year-long movement. You have to understand your own neighborhood before making claims about things in distant space. So the motion is occurring in 3 dimensions, yet we can only see 2 dimensions. So they're using a lot of free parameters to construct the orbits of blobs of light that they've observed. And I just think it's rather strange that we are enshrining these sorts of data analysis, these speculative data analysis methods that are full of so many assumptions, by celebrating them with a Nobel Prize. It's absolutely absurd. So when you see these animations that won the Nobel Prize, it's either, from some people's perspective, it's a triumph of science, but from others' perspective, it's an example of mass delusion and an irresponsible mixing of truth and fantasy. So there are several nice videos in the post below. There's one that shows how far they have to zoom in order to see these little motions. They're basically pushing their measurement tools past their limits in order to do this. And I think they are deluding themselves into believing in measurements that have been influenced by wishful thinking. So, and a lot of money goes into making simulations and measurements of these things, studying black holes. So you should expect a lot of resistance to change in belief, especially after a measurement is enshrined in the firmament through a Nobel Prize. So one practical application of this system, you can use a large adaptive antenna. If you can use a large adaptive antenna to measure something at such a distance with such precision, you can also transmit a signal with such precision. And looking at these 30-meter dishes that seem to be so popular makes me think about James Bond movies and death rays. Wouldn't it be very cool or very horrifying if you could use adaptive optics to shape a microwave signal so that it bounced off of the atmosphere and got focused to a small point, like a chicken or a human head? GPS could locate the target to within a few centimeters, and the radio antenna transmitter could deliver the energy. The energy from a klystron should be strong enough to cook a chicken, and since microwaves go right through houses, it could even cook a chicken in a house or start a fire somewhere. And I really hope that isn't possible, because that would be very disturbing. Since I believe that it is necessary to quarantine our fears about the world in science fiction, I will write a story in which a protest group plans drastic action against such a device, but completely misunderstands the capabilities of the object of which they are afraid. Meanwhile, experts understand its limitations and bring everything under control. I just find it so strange that the Nobel Prize was invented to support peaceful technologies, but it has awarded work that indirectly subsidizes tech that can be used to construct highly non-peaceful weapons. I have no idea if this Zeus-like technology exists, or if it's only a threat. As far as I'm concerned, it's technically still not possible, and that those who pretend it's possible are probably tricking us. But it is worth thinking about what the world would look like if it did exist. We wouldn't be worrying about missiles, but rather about microwave beams that can spark forest fires or fry somebody's head while he sunbathes on the beach. Given the ease with which a 30-meter dish on an island can be identified, I think this technology would be easy to outlaw and remove if everyone knew about it. Most people would refuse to ever work on something so dastardly, unless they were tricked into thinking that they were building something more peaceful, like a telescope. Recall that this is the voice of a science fiction novelist, and it is highly speculative. My technical expertise starts and stops within the narrow branch of accelerator physics in which I was trained. I'm not one of those people who dreams of escaping the planet just because I'm afraid of such technologies. I'm more of an I will go down with this ship sort of person, and I think that is the attitude that everyone needs to have to keep the world nice. The people who are convinced that the world is coming to an end can climb onto Elon Musk's spaceship and go to Mars. Bon voyage, kids. That sounds somehow a little bit shady to me too. Thanks for watching.